morning, everyone. So let's begin with today's lecture. Today's lecture is on text representation in natural language processing. So guys, last week we did cleaning of the data. We scraped a lot of data from internet. We cleaned it. We removed numbers. We lowercase them. In some cases, we use stemming. In some cases, we use lemmatization. And then we talked about tokenization. Now for tokenization, there were three libraries, NLTK, Spacey, and Whitespace. And we talked about them and we learned that which library is important for which scenario. But in today's presentation, we'll go on the step 3, that is converting now your words into your numerical representation. Let's learn that. And with that, we will also do a code on a spam message classifier using bag of words. Without a further ado, let's begin. So now, what is text representation? We all know, guys, the text representation is process of transforming raw data into numerical formats that computer can process and analyze. Now, this process of transforming raw data into numerical formats that computer can analyze and process can be learned in different ways. But before that, we need to know how does an embedding looks like. Now, embedding looks like, as you see on the screen, a typical embedding vector looks like this. A typical word embedding vector looks like this. And with the word embedding vector itself, when you look at it, you cannot make it out that it belongs to which word. But if you imagine, if you're able to compare these two embeddings, then you can literally tell that either, they represent the same meaning, or if you are plotting them in a chart, are they coming closer to each other? And we'll learn all about that. But before that, it is really important to understand why are we doing text embedding. So guys, we know that machine, they operate on numbers, right? And if the machine operate on numbers, they cannot really understand numbers. Therefore, we convert them into these numerical representations, right? Now, what are the ways to convert these numerical representations? So over the years, different models have evolved. So one of the main model, that was in development, and that we'll learn about it in tomorrow's class will be glove model and word embeddings by BERT. How can we generate it? But that is a little bit of advanced concept. Today, we will learn something more about, one-hot encoded, some of the concepts on which all these bigger concepts are built on, so that we get a deeper grasp of something called text representation. Okay, now let us see what is one-hot encoded. What is bag of word? What is term frequency, inverse document frequency, and what is n-gram? Now, all of these four things, they do similar thing. They convert a word into an embedding. Now, how do they, distinguish from each other, and when we can use, which one? What are the limitations? This is all we are going to cover in the next slides. Okay, now what is one-hot encoding? And I think people who are from computer science background, they already know what is one-hot encoding. So for example, any word that you see here, it will be a unique binary vector. So for example, on the screen, you see different words, and each word is a unique binary vector. So what is a binary vector means? Binary vector means that it will only have 1 and 0. It will only have 1 and 0. So you see here request is converted into a one-hot encoding vector where it is 1 and then all is 0. Featured is also, there is a 1 here and then all are 0. Now, how it is happening? So for these kind of experiments, what we have is a limited vocab. And limited vocab would mean that here we only have the vocabulary of 5 words, where each word is the first word has given the first index and is represented by 1, whereas other indexes are represented by 0. In the feature here, each word here, you see here, it's the second word, and therefore index 2, rest are 0. In how we see that it's a third index, and we have a third position 1. Similarly, for fourth, we have fourth, and here this is your index, and for fifth, this is your index. So this is one-hot encoding where your vocabulary is very restricted, and your each word basically the where there is a 1, it's actually the index. So overall, you represented it by unique binary vector. Now let us see here. Let us see on screen here. We have one-hot encoded embedding. So the vocabulary is very limited. So here on the screen, you see the vocabulary is, I love cat, dogs, and our friends. So this is the vocabulary. So vocabulary is of 7 words here, right? I love cats, dogs, and friends, and vocabulary is of 7 words. Now, each word is assigned an index in the vector. So here you see here the length of the, first of all, this is important. Your length of the embedding is 7, right? Everywhere the length is 7 because there are initially 7 words in the vocabulary. Now, with this, if, for example, I add to this vocabulary here, I love cat, dogs, and our friends, and I can also write, I love maybe horses. Now, if I add the word horse here, then how does a vector becomes? So my horse, so first of all, everywhere I will add a 0. So because now the vocabulary is of 8 words, so this entire thing, the length will become 8. So it will become 1, 0, 0, 0, so 4. And these are also 0. So this is a 0. So this will be I, right? Because now I have 8 words in my vocabulary. And like this, your love will continue similar, but it will have an index at 1 position. And like this, if I go and do horse at the end, then my representation will be what? It will be all 0. I will have 7 zeros. And it will be like this. So here what I did, more vocabulary I will have, I will change the length of the vector. Length of the vector goes from 7 to 8, right? So this is how my embedding are changed in your one-hot encoded style. And what do you see here? You see here this one-hot encoded is for very, very limited cases because your vocabulary size is very, very small. So at most, you can maybe have 100 words of vocabulary, or, but you cannot have here 1,000,000 words of vocabulary. Maybe you can, if you have a better computation and everything, You can maybe even go for thousands and 2,000 words. That means you're able to analyze few paragraphs, and you're able to analyze few pages using this method. But this method is very powerful if you're doing some kind of small cross-checking of certain facts. If you are able to recognize you are doing some kind of word classification, this is very powerful. Now let us look at another thing here. Now, how does the sentence representation looks like? So this is how is one-hot encoded embeddings, and this is your sentence representation. Now, in the sentence representation, what we have is I love cats. Now, what happens with I love cats? So each word is represented separately. So you see here, this is I love cats, and the sentence looks like this. So this is this is a big matrix which consists of each word. So imagine if there is a sentence like this: I love cat, dogs, and friends. This will be the entire thing will be one big, this will be a one big sentence. And you see, if we have a paragraph, how much does this become into a one big lengthy, a very lengthy matrix? Now, just look at here, love, the sentence like this: cat and dog, cat and dog are friends. Now, how does this becomes like cat and dogs are friends? This becomes like a big matrix. So even this, as I told you, this entire thing can be a one matrix. If I'm looking for the sentence, I love cat, dogs, and friends, this is one sentence, right? So overall, this is what you call as one-hot encoded embeddings. What we learned is, first of all, the length of the vector is equal to the vocabulary size. So here the length of the vector is 7 because the vocabulary size is 7. So here vocabulary size is 7. So length of the vector is 7, right? So this is one main takeaway. And then other takeaway from here was that it literally matches the index or the position of 1, right? And the third main takeaway is that a sentence looks such a big matrix, right? Okay, now moving on. I think there is one little thing. So one main thing that we have here is that in one-hot encoded embedding, why this is not used for a lot of your high or advanced projects. First of all, we cannot have a very have a very huge vocabulary, right? We cannot, because more huge vocabulary you will have, you will have issues in the computation, because each sentence is represented by such a big matrix. Now, what is other limitation? Other limitation is that, okay, each, there is a word is getting transferred into the vector, but it does not represent any relationship between them, right? There should be some relationship between words. So, which is a very crucial thing if you are doing, or working with a language, that there should be some kind of relationship trapped between the words. So this is the two main things. One is that we cannot go with a very big vocabulary size, and there is no, how to say, a link between the words, right? These words are independent. Okay. Now let us look at something that I taught you last time, is bag of words. Okay, what is in the bag of words? And most of us should remember this, because we did bag of words last time. If you go to the recording of last session, we did bag of words. and it looked very similar to hot vector encoding, but it was slightly different. Now, in bag of words here, it is literally like this, bag of words. What does that mean? It means that we do not preserve the grammar and we do not preserve the word order. There is no grammar and there is no word order. So what is happening here? So for example, you have a text. It is a puppy and it is extremely cute. Now, this is your raw text. Now, what we'll do is we will chop this grammar and we will clean it. We don't need this, right? And now, we chopped off this grammar and there is no word order. So you see here, this is a bag of word vector, and I will go in detail in the next slide, but there is no word order here. And what is the other difference as compared to your hot encoded vector? In the hot encoded vector, it was a binary vector. But in the bag of words vector, what do you see here? We have here your frequency. Your frequency of words. Now, this is your bag of word vector, and this is your raw text. So this is some main takeaway from bag of words is that no word order, it disregards grammar, and then we have a frequency of word. Now let us see how it's working. For example, now with the bag of words, we have here, you have a vocabulary. I love cat, dogs, and our friends. Okay, we did that last time, right? I love cat, dogs, and friends. Now, the sentence, so this is, guys, is again your vocabulary. The vocabulary is not like, your dictionary or Wikipedia. This vocabulary is of 7 words here. This is your vocabulary size. Now here, I love cats. So your bag of vector becomes this. So again, here, the index is maintained. I is your first word, is your first token, Your love is your second token. So this is your first, this is your second, this is your third, this is your fourth, this is your fifth, sixth, and seventh, right? This is the size of the vocabulary. Now your sentence, I love cat, it becomes like this. I love cat is, this is your becoming bag of word, right? You remember here, the word I is there, it is putting 1. Love is there, it is putting 1. Cats is there, it is putting 1, and rest is 0, right? And if this I was doing in hot encoded way, how was it? I love cats. This vector, it was a big vector. Now in the hot encoded one, it was I love cats. 1, 0. Then I love, it will be, love is the second word. Okay, we are lucky here. And then cats will be, this is the hot encoded one. So bag of words already does that job, right? It makes your matrix into a very, very small, it shrinks it. It shrinks it, right? I hope it's clear to us what is bag of words and what is hot encoded. Hot encoded, you only have, 1, 0, 0, 0, 1. But in the bag of words, you will see we also have the frequency in the next slide. And then how is the vector in the from hot encoded, it shrinked into this. Okay. Now you see here, I had I love cats. Now I have I love cats and cats. Now, what happens with I love cats and I love cats and cats? Now, you have cats and cats. This word is twice, right? So initially, your vector was I love cats. It was 1, 1, 1, 0, 0, 0. Now I become I love cats and cats. So how it is becoming, guys? So you have also another word here, and, right? And was at position 1, 2, 3, 4, 5. It was at position 5. So you see here, the vector becomes, okay, I is at 1 and its count is 1. So it is at 1. Love, its count is at 1. So it is here. Cats is 2, right? Why cats? Because the frequency is double and it is the third, word in your vocabulary. That's why here. Now dogs was the fourth word. So it's 0, right? Now, and is again fifth word, so it is 1, right? And 0, 0. So this is your bag of words. So this entire vector here, 1, 1, 2, 0, 1, 0, 0 is bag of word. So this is how it's even much more powerful than your one hot encoded one. So I hope this is clear, that how bag of word is different from one hot encoded. Okay, now what we'll do is, before we move to another type of models, we should do a one code in which we will do a spam classification system using bag of words. Okay, we will do a code. We will try to understand why bag of word is so important and why we should know this technique if we are learning LLM. Okay. Before that, does anyone have any question about anything? Because we will jump to the coding activity today. I see nothing in the chat. Okay. So what is a spam classification? So you have a lot of emails in your inbox. And what do you see in the emails? In your emails, you see there are a lot of unwanted and irrelevant emails. These are your spam, right? And anything that is your email, that is your legitimate email, you can say, or a true email, or email from me about this workshop, or email from your company, these are all legitimate emails. So we have two categories. And what I have done this, I would be running a very small demo code for you to build that understanding. And then I will talk about, how is the bigger or more industry grade project is run based on this understanding. Now, here I'm just taking a very, very easy sample data set, and I'm only taking 4 or 5 messages. So you see here the message is, win a free iPhone now. It's a spam. So this one, win a free iPhone now, it contains the words like free and win. Then there is another message in the list that is a spam. It's also won, right? So these are my, so I'm trying here to understand my patterns. So the words that are in the spam messages are win, free, won, right? So these are the words that are linked to spam messages. Because this is a small data set, so it will only be able to classify the messages that have these words. Now, other is a ham. So ham is here, meeting at 5 p.m. today. This is your good one, right? This is your ham messages. So please don't take it like, cross is bad. It's just, I'm trying to distinguish here. So this is good. Meeting at 5, 5 p.m. today and let's catch up soon. These are your ham messages. Okay. Now you will have this data set. Now what we are doing this, we are breaking each message into individual words. That's what we do. Once we receive it, we try to tokenize it. We here, try to tokenize it. As you see here, when free iPhone now, there are 4 tokens here. Meeting at 5 p.m. today, there are 5 tokens here. So this is 4 and 5. Now going here, now what we'll do is, from the previous one, all these things becomes our vocabulary, right? So we have tokenized it. We only had 5, 4 or 5 lines of data set. We are tokenizing it. And after tokenizing it, the vocabulary looks like this. So now vocabulary consists of how many words? Let us see. It consists of word 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Right? This is, so my length of vector will be 16. So let us see here. This is the 16 word vocabulary here. So my length of vector is 4, if I just counting 4, 4, 4, and 4, 16 length vector. Now with 16 length of this vector, I can represent any sentence, right? So this is my bag of word representation. So actually, if you see it, I was able to convert this big sentence into a vector, right? Into a meaningful vector. So if now you have the capacity to build any new sentence, let us quickly build a new sentence here. Okay, let's build a good sentence. You won an iPhone. You won an iPhone. This is a sentence. Now, what will be the vector representation of this? You won an iPhone. Can anyone put that in the chat? What would be the vector representation for you won iPhone? Looking for some interaction here. Okay, looks like you're working on it. So you is at 11th position. So there will be 11th position from here. 7, 8, 9, 10, 11. That I can put a 1. Won is at 12th position. I can put a won at 12th position. iPhone is at 3rd position. So I put it, iPhone is at 3rd position. So it became now, you see, rest is all 0. Isn't it like a small puzzle that you have that converted your everything into a vector representation? So using this vocabulary, you can, do a lot of, cool sentences and can do it. Now, after that, I will introduce, or I will use something called a naive Bayes or a logistic regression to classify my spam, right? So it's basically a machine learning algorithm, and some of them you should know if you are doing, are building advanced projects, because you will use them here or there. So now using this, so we have these vectors, and now I will classify them using a naive Bayes or logistic regression, or I will train a classifier. Okay. Now, guys, what did we learn in the back thing was my spam messages, it contained a word like won, free. And my ham messages, they contained a word like meeting. It contained the word like, work or project, something like that, or my company name. It contains all these words. Now, with the little vocabulary we are training that any message that comes with won or free should directly be put into spam. That is the intention behind this project. Any new message that comes with meeting, work, project, put it in the ham. And to do that, we are training our model in a way, and we are using, and this thing can be done, even with the hand, because we are using a very, very small data set here. Now, we are using something called naive Bayes. It's all based on the probability. So what is this naive Bayes doing? So naive Bayes is doing is, the new message that comes, right? The new message that is coming, how much chances that that message is a spam? It is directly proportional or equal to probability of, words in spam. That means, what is the probability of those words that the message contains belong to the spam? And what is the probability? And that can be calculated, right? That can be simply calculated if you go here and you remember our big vocabulary there. If we go back there, the big vocabulary here, it's of 16 words. So we can calculate that probability, right? That we have 16 words, and out of those 16 words, what is the probability that the word that the message contains belong to the spam? So here, the words that we have, maybe, you can say here free, or you can say won, or you can say, win, and maybe, I don't know, congratulations you want to say, but let us say congratulations, because it comes up in your spam messages a lot. You won this, that. So there are 4 words out of 16 here that belongs to spam, right? Now, so this is the probability of words in a spam, right? Or the spam words in a message. And what is the probability that the message is spam? How much is the probability? So if we go here, how much is the probability that your message is a spam? The probability is 2 out of 4 messages in this data sets are spam, right? 2 out of 4 messages, because this is spam. This is 1, 2 out of your 4, right? So for example, you have an inbox, and out of which only 4 of them out of 400 are spam. So your probability is 4 by 400 that this is the actual spam messages that I get. So I will take care of this probability in mind, and I will multiply it with the probability of the words in the spam, and that will give me what we call it as the total probability of, of that your likelihood of your that message is a spam, right? So this is your naive Bayes here, and it's very easy, as you saw, because I'm doing a very, very small data set. But naive Bayes, you can even run it on, easily upon with 20,000 words. You should be able to do it. I have done it on 20,000 words, and 20,000 words is a good token words. So if I give you today, go and start scraping Amazon, and look on the Amazon, for a product, that it is a good product or a bad product, and you start scraping all the reviews on, something that contains 30,000 Amazon reviews, you should be able to run this model. And we should be start doing those projects. Go and scrape Amazon reviews and now build a classifier that tells you it's a good review or a bad review. And these small projects, guys, will take you to bigger project, right? Okay, now let us do the code. Okay, guys, before we run the code, I want to also tell you one thing. See, this is what is in machine learning algorithm that you are doing is, this is your training data set. So right now you have only your 4 messages, and you will convert these 4 messages into your training data set and your test data set. Because your data set is so small, so you can say your 4 out of 4, I give 3 as my training and 1 is a test data set. So this is your X train, because you will also test your model, right? And this is your X test, right? And then with that, you will also, because you are doing something called machine learning, so you are doing something called, you are training your model, right? Now, what is happening here is, you are training would mean you are training your model to say that it is a spam or it's a ham. You are training it intentionally. So training would also contains label, that is your Y test, right? And your Y test will be your training, and your Y test would be the label. So here in the training data set, you will either have some messages will be spam or ham. This will be your label, right? So this is train. And your Y test will also be the same, right? So you divide into your data set into train and test, and each train and test will have its label, right, attached to it. So overall, what we can say here is, I divide this top 3 into my train and this one into my test, right? And each message is attached to a label, and this become my Y train, and this become my Y test. I did not include the third one here. Yeah, these 3. So this is how your data set is divided. Now, if I add more sentences there, it will, your data set will keep on adding, your vocabulary will keep on adding, right? And that we will see now. Let us do the code. And I can also do it. So right now, your messages was, 4, right? So I can split it. So I use, split my data set. So I can use a number 0.2. I can also use a number 0.5, 0.7. What it will do is, it will, if you do 0.2, that means 20% of the data, which will be 20% here, 20% of 4, that will be in the fractions. So let us see 25% of here. If you keep this number 25%, 1 will become as your test. This is known as splitting your data set. If I do 0.5, then you will see your half of them will become your data. Now let us see this in practice, and it will be more clear to you. Guys, any question, please keep on writing if you don't want to speak, but most of your, you can also speak. I'm open to it. So guys, here, okay. This is your first important code. Now, what I'm doing is, these are all the libraries that you have to import. And you will learn about these libraries. And this is very important in a way that libraries generally vary, with respect to the project that you do. Now here I am calling something called scikit-learn again and again, because scikit-learn is an important library for your ML models. For anything where you are doing machine learning, that's what we are training our model. scikit-learn comes up with very good libraries for that. Then we have something called pandas, we have matplotlib, and we have SNS. This is the three libraries. So pandas are excellent when you want to do, you visualize your arrays, condensing your arrays and stuff like that. Matplotlib is good for the plots, and also Seaborn is very good for visualization. So you do all these things here. Now, these are your different libraries. Now you have messages like this, right? So here, let us now see here. So this is something that you control, right? I can also add another one here. See, I will do here. I will add another one. We have 5 lines. I will also add another one here. These are your messages. So one message that I can add is, let's catch up, or I can write, let's win a lottery. This is your 5th message. Like this, you can keep on adding the message, but you will also have to provide these labels. So now if I run this code, see, my code was here. And if I run this code, it would not run because there are 1, 2, 3, 4, 5, 6. And you win a lottery, I inserted at the 5th position. So my 5th position should be also becoming spam here. Otherwise, it will show me an error. So this is the label that I'm putting, and these are the messages I'm putting. So this is the data set that I'm providing. And in the code, which is later on, I have loaded the data set, but this is coming from internet. But here, if I go online, what is in the code here is a data set which is coming from 425 spam messages, right? And there's a 10,000 legitimate messages, which you can, go and look into it. But right now, I want to run a sample code with you guys. And this is in the later thing. And it also uses exactly the same code, which I am teaching you on top. But I am teaching you on top a smaller code because it is very easy to build that foundation or the concept in your mind. Okay, so we have all these here libraries. I have inserted here my messages, and I have inserted here another message. Here is a spam messages. You win a lottery. Okay. Now, if you see, the entire code is only this first cell. This is the smallest code. But you can definitely go and do a lot of things within each step. Now here, after I have done the libraries, this is my data set. Now what I am doing is, I'm converting this into the bag of vector representation. Now, how do I convert into the bag of vector representation? This is something called count vectorizer. What does this count vectorizer function do? It just convert this is a function that I'm calling. It will convert everything into the vector that we talked about, right? That this line, for example, can be converted into your 16 thing, right? 16 thing, and there would be at 4 places, there will be 1. And this is done by count vectorizer. It also counts. So for example, there is a word called let's catch up soon. It should be giving me 2 somewhere. So after vectorizing it, let's get into the step of looking that, we have vectorized it. So here, now, you see here, this is my step, and I have converted this into bag of representation, and I use this vectorizer. Now let us run this code. And see what it gives me. It should not print the error, I hope. Okay, it has given me the error here. Input variable with inconsistent number. Okay. So let me then again inconsistent number of samples, 5th and 6th. But I hear 1, 2, 3, 4, 5, 6. Here is also 6. Now, what is the problem that happened here? Maybe I did not put a comma. Let us run again. Yeah. It gave me a 0.5 is the accuracy. Why is my accuracy only 50%? Because my test size was, only now what I'm happening is I can play here with the test size. So you have to be patient just on understanding this code, what it is doing. Now, if I give the test size equals to 5, let us see the accuracy changes. It becomes 0.6. And if I give the test size of 8, it becomes this. And if I give a test size of 1, what is happening here? Accuracy becomes 1. Now, what is happening, guys, here? Can anyone give me any input here? See, what is happening in the test size? You have your initial data set into 6 lines. Now, when you do test size is equals to 0.1, that means your train contains 90% of your messages are in your train. So 90% of this, let us say 5 out of 6 is in the train, and test is becoming your 1. And this you are controlling by this. When I say 0.2, in that case, your test becomes 2 and your train becomes 4. This is I'm splitting it. But why it's changing that frequently? Because I have a very less data set, because it's a toy code. Okay, but it still gives an understanding about splitting the data set into test and train. Okay. Now, after doing that, let us see here. I converted. So what I'm doing is, see, guys, this was the step 1 that I took it from vectorizer, count vector, and then transform these messages. This is the code I had. Now I want to do something so that you can visualize it. So to visualize it, what I'm doing here is I am converting it into this form. So just I'm printing it. I want to print the bag of words data frame. So let us see here. And you have to imagine that this line here is continuing here, because this is a printing, that is an error. So you saw that there were 16 words. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a big message here. Now, when a free iPhone label is attached to it, spam ham, and now it has only So let us see here. I did this is my only training data set. If you see here, let us see here. I ran the code, and in the code, we have this data set, spam, ham, spam, spam, ham. I added this word, let's won a lottery, and it converted into this big vector data set, right? And after that, I converted it into this big vector data set. Now here, I am just right now haven't converting this text into bag of word representation. Okay, I just use my vectorizer to convert it. I have still not split the text. And what I'm doing here is printing it. So I'm just saying message label. So put the message at the first row, label message at the first column, label at the second column, and then we are vectorizing it. Okay, and I'm printing it, right? And now I'm doing my splitting here. I was still at the step 1, converting it, visualizing it. Now, do you want to try and see more? If I add another line, does it add another label? Yes, it will. You want to quickly see it, or you're good? It will keep on adding it. Let us try to delete it. Let us see what it becomes. We delete it. Guys, I want to develop this intuition in yourself that you should be able to play with this, because this will change your accuracies and everything. So now I again went to a smaller data set. Now it is showing me this. Now there are only 5 lines here. Here are also 5 lines. It is doing this. 1, 2, 3, 4, 5. So our code is working. It is converting my initial messages into these bag of words embeddings, right? Perfect. And here I'm just printing it. After printing and seeing it converting into the embedding, now I'm using something called naive-based classifier. Now I have started splitting my train and text. So this is my messages here, and I am trying to split it, right? And after splitting it, now this becomes, I give it 0.5. That means I can be in the same thing as below. I'm just trying extra steps here, and it has split it into 1. Okay, very good. And now I should keep it same everywhere. Now what do you see here, guys? I have split my data set into my train and test. I am getting my vectors out, and I am kind of printing it. Print my xtrain with labels. So now my test size was 1. So that means my train size is 0.9. So what is happening here? Spam, spam, ham. Only 4 messages are in your train. So it just randomly split. Here we had, 3 messages of spam and 2 of ham. Here it becomes 3 of spam and 1 of ham, right? So splitting the data set will change everything. This is one thing I'm talking about. And when you develop a project, you can play with it. And here now, one of the ham messages was in the test data set. And I'm not printing your test data set, but if you want, we can print your test data set too. So for that, you just have to do one thing. Copy this cell, right? And you can add the code. And this is your xtrain, xtest, same thing. Now you can convert this into test here. This is my test here. Convert my test to array. And now here my test. And this will be my test. And this will be my test. And this will be my test. And print text with labels. And you can see there would be one message in the test. This is an important knowledge from here. There is only one message in the test, right? One ham. And I can constantly change it, guys. If I do here 0.2, okay, let's do 0.5 then. More messages, 50% of them coming here. There is a question in the chat. Thank you. Okay. So this is we have converted into spam and ham, right? Now, after converting into the spam and ham, now what is happening here is we are now, training our model. Do we have any question at this point, guys? This is a very, very key messages in converting your original test data set into train and test, right? We have converted it into now train and test, and I'm open to questions. After that, my entire message is converted into these vectors. Okay. Now what is happening? This was my step 2 to convert it into vector. Now what is happening if you are converting it into vector, then you are training a model, which is your naive-Bayes model, right? And your naive-Bayes model here, now with the naive-Bayes model, what is happening is you go here, convert it into it, and now you are doing some kind of your prediction here. So model.predict. The model that we used here is the model on top. And now here, we already saw in the above model, our accuracy was 0.5%. Guys, I will summarize it for you. So just please be patient here, just a second. Now, what is happening here is, congratulations, you have won a new lottery ticket. Now, this is the new, so now your model is trained, guys. So your model was trained here. So this is the key of your model, right? So do not get confused here. It is because you are a beginner here, will be slightly confusing. So you have a message here, right? And after this messages, they convert into this big representation of 1, 1, 1, 0, 0, 0, 0, and so on. Now you are converting your messages into your train and test data. This is your X train. And this is your, X test with their labels attached, Y train and Y test, right? Now you are using this model multinomial. Please train this model. And this is coming from scikit-learn. And you're fitting it on your data. So fitting it on your data would mean that you're telling that your X train should correspond to your Y train, and your X test should correspond to your Y test. This you are training, right? And after training, you are predicting them, right? Now you are predicting them, and you're making a prediction on X text, right? X test was the one that you just separated it out of 4 and 3. You are making a prediction on this one, and you're making the prediction, and you're calculating your accuracy on this one, right? This is the net thing, right? Importing libraries, this is your data set. You vectorize it, you split it. After splitting it, you will run the model on your train, and you will do the prediction on your test. That's what you're doing. You are, fitting it on your model X train and Y train, and you're making the prediction on text, because test is the new data where you want to make the prediction. And finally, you have the accuracy score, right? So this is how this entire pipeline works. Now, what I have done here is at the bottom, just for a better visualization, I have started playing with, I have started playing with visualizing it. So this is, if you see step one, it's just visualizing your, your bag of words representation, and we all agree we saw. And now, again, I'm just trying to show you how the split size you can play with. And here you're just splitting your split size to just change into test and train. And I showed you that, this is how you can split your data. After splitting your data, we already trained it on your test data set. So now we already train it on the test data set. Now you are training it on test data set here. And I am now, after you have trained it, now what I'm doing is I'm giving it more new messages to check, and please do if it is a spam or not a spam. And we can quickly check here any word that I give here. See, I give another word. Let us just test it, with a message here. Let us just test it. Won a lottery. What is the, it give me, it's a spam. We have a meeting. It will give me ham, right? Meeting at 5. So this is your model has been trained. It give me ham. And all the messages that I'm giving here, it only comes from this library. Won an iPhone. These are my messages that I'm playing with. Spam. So ultimately, this is what we did in this. Guys, any questions here? Yes. Yeah, I know it's, yeah, we are, but we're still on time, guys. Class that I have is 1 hour to 15 minutes. So this is, I hope this message is clear to you. How are we running this thing? Converting it into test and train, and now splitting it into, fitting it and training it. Any questions here, guys? Are we clear on the code? This is a very, very important code. Okay. Now, after running this code, what I want you to build, this is a homework that you will do. This code is will be in the drive that I shared, and I will share this quickly. Now, you will build a spam classification using the hot encoding model. Now, how will you build a spam classification using the hot encoding model? Now, you will do the same thing. Now, in the hot encoding model, see, this will be your initial vector that you will give. Here you have these, top 10 words, and you will give them as your initial vector. And you see here, the vocabulary won't be very big, very small vocabulary. But why this hot encoded is so important, guys? For example, now you can go here and use, something like print your counterizer is binary true. In the past, we use a count vectorizer. We did not use the binary true. And this time you will use the binary true. This will convert it into one hot encoded. And after that, you converted it into one hot encoded. Now you have here one hot encoded. And this is the big vector size that you have. And now what you can do is do the same code using this. Now, why one hot encoded becomes very important to us? See, in the text classification cases where you do not have frequency of numbers, for example, today I have a document, and in the document, I have something that will, take us, has the keywords like, finance or dollar or euro. And we have here 100 documents with us. And you want to classify a finance document, it will immediately, with the word dollar and euro, it will pop up, right? So where there is only, we are finding the document which only has one word and doesn't have a repetition of a word, one hot encoded will do a good job. And it doesn't have it will be a small project, as I told you, the Amazon review thing, and it will be able to develop. So this is something that you will do as a homework in the one hot encoded, and I will share this code with you, and we'll resume tomorrow with other two things, that is TF-IDF and the n-grams, and we'll talk about it. But this is here, this was your first code, guys. It is an important code. I hope you enjoyed today's lecture, and let me know if you have questions. I'm open to discussion. Yes. Any questions to anyone, or was it difficult? Because you are beginners, I try to really break it into very small steps for you, but I hope the code was clean. I know most of you have a shorter 1 hour thing, but I always try to have 1 hour 15 minutes because of the coding. Guys, you have questions? Yes, there is one more question here. Okay, so let us resume tomorrow, guys, same time. Bye-bye.
Take care. Thank you.
Bye-bye.
Thank you. Bye.
Thank you.